Welcome to This Explainer. Today, we're going to completely change how you look at that unassuming metal box hanging on your garage wall. You might think of a solar setup as just some panels on the roof and a battery on the ground, but today, we're going to see how the hybrid inverter is far from just a passive converter. It's actually a genius, real-time energy brain that literally dictates how your home breathes and uses power. So, let's dive right into it. Think about it for a second. When the sun is shining brightly, your panels are generating electricity. Your fridge is running, the AC kicks on, and your battery is just sitting there. But who or what is actually in control of routing all that power? Who makes those split-second decisions to ensure your lights don't flicker, all while keeping your energy bills as low as humanly possible? That brings us to Section 1, the real-time energy brain. To really get this, we need to shift our mindset. We have to start seeing the hybrid inverter as a strategic processor, not just a static piece of hardware. When you look at the different roles in your system, you've got the solar panels bringing the energy in, the battery on standby, and the house drawing loads. Now, a lot of people think the battery is the brains of the operation. But honestly, the battery is just the brawn. It's the storage tank. The hybrid inverter, sitting right there in the center, is the active brain, directing all the traffic.
And it doesn't just make random guesses. There is a CPU inside that is constantly evaluating its environment. Literally every single second, it recalculates variables to answer 4 critical questions. First, what's the current solar production? Second, what is the current load demand from the house? Third, what's the battery state of charge? And finally, is the utility grid actually available? It processes all of this data instantly to execute a program strategy. The absolutely crucial point here is that it has to obey the law of instantaneous balance. Basically, energy generated must exactly match the energy consumed or exported at any given millisecond. For example, if your solar panels are producing 3 kilowatts, but your house suddenly demands 5 kilowatts, well, you've got a negative balance. To prevent a blackout, the inverter calculates this instantly and commands the battery to supply exactly 2 kilowatts to maintain perfect stability. No flickering lights, no power drops, just seamless math happening in real time. Moving right along to Section 2, the default power hierarchy. But how does the system actually know whether to pull that energy from the battery or the grid? Well, unless you tell it otherwise, the inverter follows baseline rules, a programmed priority logic. For a typical residential setup aimed at self-consumption, the logic is incredibly straightforward. Step 1, use available solar power first. Step 2, if solar isn't quite enough, tap into the battery. And Step 3, only use the grid as an absolute last resort. The whole goal here is to maximize your independence and minimize the energy you have to buy from the utility company. Think of it like a highly efficient, automated waterfall of energy. The golden solar power flows first to the active house loads. Then, if there's a surplus, it cascades down to charge up the battery. It's only when the battery hits its maximum allowed limit that the system even looks at the grid. Which leads us perfectly into Section 3. Daytime dynamics and following the sun. To really grasp this, let's walk through a practical daytime example. Say it's noon. Your solar panels are generating a healthy 5 kilowatts of power, but your house only needs 2 kilowatts to run the fridge, some lights, and a fan. The inverter instantly does the math. 5 minus 2 leaves a 3 kilowatt surplus. Rather than letting that energy just go to waste, it automatically routes that surplus exactly where it's needed, straight into the battery to store for later. But what happens when that battery eventually gets completely full because it can't accept that 3 kilowatt surplus forever, right? The inverter has to manage this instantly. Now, if your system is permitted to export, it'll send that surplus out to the utility grid, which often earns you credits. But what if the grid is down or your local utility just doesn't permit exporting? And this brings us to a seriously fascinating feature called curtailment. The inverter doesn't just continuously force 5 kilowatts from the panels and blow a fuse. Instead, it actively throttles the solar panels. Using MPPT, or maximum power point tracking, it deliberately steps away from peak efficiency to generate exactly the 2 kilowatts the house needs, perfectly matching the load. It essentially just tells the solar panels to chill out. Let's transition to Section 4, after dark operations and shifting to storage. Let's move the timeline forward to sunset. As solar production drops to exactly 0 watts, the house still demands that 2 kilowatts. The inverter performs this instantaneous handoff. The battery steps up and becomes the primary active energy source. It maintains a continuous flow of power to the house without drawing a single watt from the utility grid. You are completely self-sustained. Pretty cool, right? But remember, the inverter is also a protector. It continuously monitors the battery's state of charge, or SOC for short. This is a critical software boundary, a minimum limit programmed right into the inverter, like 20 or 30%, and it's specifically designed to protect the battery from excessive discharge, so you don't destroy the internal chemistry. Because if you drain a physical battery all the way to absolute zero, you heavily stress the hardware and drastically shorten its lifespan. So the inverter intentionally stops discharging in the safe green zone. This extends the service life and prevents the battery's internal hardware, the battery management system, from panicking and performing a hard emergency cutoff. And trust me, nobody wants a panicked battery. So let's say it's 3 a.m. and the battery hits that protective 20% limit. The inverter recognizes this instantly. It immediately ceases battery discharge and perfectly switches over to pull that 2 kilowatt load from the utility grid instead. That remaining 20% in the battery is safely preserved, sitting there exactly as it should be, all while the house stays powered. All right, Section 5, Beyond Defaults and Customizing Your Strategy. Everything we've talked about so far is just the default setting. But the real beauty of a real-time brain is that you can program it. First, though, we have to debunk a major myth. The idea that 0% on your app means a completely empty battery, and that you should use all of it. The reality, as we just saw, is that setting your minimum SOC too low actually damages your physical investment. The inverter acts as your daily software manager. It sets an operational floor, say 20%, so you never hit that physical hardware danger zone. But setting it too high means you waste potential daily savings by relying on the grid too early. It's a really delicate balance managed entirely by the inverter. You can actually tell the inverter what your specific goals are by choosing an operating mode. Self-use minimizes the grid to save you money daily. But if you live in an area with constant blackouts, and let's face it, we all know the absolute panic of a sudden neighborhood outage, you might select backup mode. Here, the inverter actively bypasses a full battery and uses the grid for daily loads, preserving your battery near 100% just in case of an emergency. Or if your power company charges wildly different rates depending on the hour, you can use time of use mode. In time of use mode, the inverter gets incredibly strategic. It can actually be programmed to pull power from the utility grid into your battery in the middle of the night when electricity is dirt cheap. It stores that cheap energy and then discharges it to run your house during the afternoon when grid prices skyrocket. It can even force a grid charge if it receives weather data about an impending storm, making sure you have a full backup before the wind even starts howling. Talk about a game changer. Finally, Section 6, the strategic evolution. We really need to leave outdated thinking behind and contrast the past with the present. In a traditional off-grid setup, a battery is just a static survival mechanism. It works until it's exhausted, and that's it. But in a modern hybrid setup, the battery is a highly dynamic, strategic resource. Because the inverter is constantly communicating and routing power, the battery is managed continuously for cost optimization, safety, and independence. Ultimately, the hybrid inverter is not simply a passive converter. It's a continuous energy manager, deciding exactly where the next watt should come from and exactly where it should go every single second of the day. So now that you know your hybrid inverter is calculating every watt in real time, what strategy will you program your energy brain to execute?